Hello everyone, this is a tutorial about RapidMiner, and today we are going to learn how to use RapidMiner for doing data mining exercises. So as a first step, you have to download RapidMiner. For that you can go to rapidminer.com and you would see this website where you can click on download, and then it's going to be at the bottom. So you see this page according to your OS installed. You can install by clicking in here and it would start downloading a file, and you can see here I have it already downloaded, so I won't do it here. So I would just cancel it and we can go back and install it. So once you have installed this, it would be somewhat like this on your desktop. You can double click and it would open. So once it starts loading, this window would look like this. So once it has loaded, it will give you a little bit idea about how to quickly introduce yourself with the RapidMiner, but since I'm going to give you a demonstration, I'm going to ignore this part. So this is your default view. You have two different perspectives to look into RapidMiner. First is your design perspective, where you can see repository panel, operators panel, and then here you define a process just like an enterprise miner, and there you can define different parameters according to the operators we would be using. In here you would also see an help window at the bottom right, which you can see about different operators and their descriptions and the kind of input and output parameters that they take in. So once you have the process defined in this window, you have the results in a different perspective that you can see in this view here. So once you have something defined here, you would have your result displayed here. So I'm going to give you an idea about how to create and import the data where I can save my own files and I can do the job. So to create your own repository, you can click on this window and you can create a repository, and then you can click on next, because that would be a local repository, and give your alias name, where I would give as my tutorials. And instead of using a standard location which is going to be inside your RapidMiner folder, I'm going to save it somewhere wherever you feel like saving it. So I'm going to save it here on desktop, just as in I have created a new folder already. So I'm going to place everything, all the data and the processes I would define inside this folder. So just select this, write your names and click open. So everything is selected, click finish. So you have your my tutorials already defined here. Now inside my tutorials, you basically have two folders, subfolders. One would be the data, where you can save the data like CSV files or text files, and the other folder would be your process. The process is like however you want to mine your data. So the different steps or the operators you would use inside this window, that's called a process, and that process can be saved inside the subfolder named as process. So I'm going to create two subfolders inside this, and I would create like this. One would be data and the other one would be process. Okay, so now that two subfolders are already created, I would also like to mention that you can move these panels one over the other, or you can hide them according to your need. So as and when you modify this view, you can change it back going into your view and restoring it as a default view. So it's up to you how you want to place these subtabs and according to your convenience. Okay, so let's import the data. For that you can select your folder, click add data, go to my computer, wherever you have the CSV file or the text file, whatever is saved, and then we would going to just select that file. Mine is house prices, so you can select the file, click next. Now this window you can just keep it like this, because this is a specific data format and this is going to be Windows or according to your OS install. Just keep everything like this, click next. Now in the next window, if you have your column fields as numeric, just keep them as integer. But if you have anything like categorical variables, like here we have neighborhood, east, west, north, south, so that's going to be a polynomial because there are more than two categories. But in the break field we have either yes or no, so this is not a polynomial. We can just change it to binomial because we only have two values here. Then click next, and then you can just give a name here, something like house price data, and that's it. Click finish. So it would save your data and it would execute this step, and it would try to demonstrate the columns of the data set you have imported. So you see here, this is my data here. One is like home numbers, and this would be automatically inserted by the RapidMiner. This is just row numbers for different dataset rows instances. This is the price value of the houses. This is the square feet area. These are the number of bedrooms. These are the number of bathrooms. These are the offers related to that particular house or home. And this is the brick. Is it a brick house or it's a wood house? And this is a neighborhood, which side of the town it is, east, west, north or south. So you can see here the result tab is actually displayed here, and you have various sub tabs inside this, where this is the data, this is the statistics, where you can see each of the column values here, like you can see minimum, maximum and other heuristics. You can actually click on any of these to see the histograms of each of these column fields as well. So accordingly you can have a data exploration kind of thing here very easily, you can see very conveniently. And for the categorical variables, you have an additional advantage where you can see the values, and since we only see here, we are actually a little bit surprised that we do not have any south value. We only have 3 values, east, north and west, and this is the fraction number or the percentage of the values they have. 45 is the count for east value, 44 for the north and 39 for west. We do not have south. So this is the advantage of using the statistics or the data exploration tab, where you get to see your data more closely, and accordingly you can take your further steps. Like I'll be taking this care here. I would elaborate this. The next tab is charts, where you can see different charts in here, and you can select different type of charts here itself, like scatter, multiple line series. So you can select, you can change all your tabs here, and accordingly you can display various graphs and you can see your data, explore your more data. And then you have advanced charts as well, where you can actually configure your own charts. You can give your own title, you can give your own legend, axis and colors and plot and frame background, etc. for each of these individual attributes, and then accordingly you can define your own charts. So this is pretty convenient, and this is very user friendly, and that's why RapidMiner is largely used these days. Now coming back to the data mining steps, we are going back to the design tab, and here we are going to do our process. So to begin with, to import our data into the first step, we have to just drag this and drop it in the process window. So your data is already present. Now our first step would be to check for the correlation between the various attributes which are present in this data set. For that you can search for an operator called as correlation, and this is the correlation matrix. So as soon as you drag and drop this, your process or the operator is present here. Now you have to join these. You can do that manually by dragging and dropping in here, or else what you can do is you can select this icon. This would automatically connect all your operators from each other. And this connection, this is actually the part of the process, just like you have in the enterprise miner, and these connections are actually called a spline in here. So once you click this, it would automatically get selected. So once you have them selected and everything is displayed here, you can click on this button, which would execute and give you the output. So this is going to give you the correlation between various attributes present on this data set, and the results would be like this. So you can see here the attribute name and their weightage is present here, and you also have a correlation matrix tab which you can select, and you can see here the price value is varying positively with home and square feet and bedrooms and bathrooms, but it has negative variations with the number of offers. So as the number of offers increases, the price of that house would decrease, and which is actually pretty easy to comprehend, right? This is correct. And it has a positive relation with the brick and the neighborhood attributes. So this is pretty convenient. Again, you can see, you can easily understand how your data looks like, how the different attributes are related to each other. And again, you have various types of tabs which you can look through on your own and you can explore more and more. Now the next step would be to go back to your design, and I'm going to remove this correlation matrix here because I already know that there are four or five of the attributes which are going to take more weightage while doing a data mining. So to remove this correlation, I'm going to right click on this and delete this. Now the next step is to select the number of attributes or the attributes which are going to be taking part in our data mining process. To do that, you can search for the operator called select attribute. So once you have this, you can just drag and drop here, and again, since once you can click on this, it would automatically join. So to select the attribute, you can select on this operator, and you on the right side you can see the parameter panel here. For that, you can select the subset, because we are not going to select all of the attributes present in here, because we earlier saw that there were 4 or 5 of the attributes which were taking part and had more weightage in them. So just for that purpose, we can select this and then click on select attributes. So I'm going to take here bathrooms, I'm going to take here neighborhood, price, square feet, and offers. So I'm going to select these 5 attributes, and to select them into your model building, you can click on this arrow and then click on apply. Now the next step is to give the attributes different labels. Like in the attributes 5 which we have selected, the price, if you see here, the price is going to be our target variable or the dependent variable, and other 4 are going to be our independent variable. So accordingly we would give the name. That would be our next step. Now also we have to notice that out of these, neighborhood is actually a categorical variable. Now for the categorical variable, to do the linear regression modeling, we have to do the parsing. So to do the parsing, you have to go for dummy coding, and I'll tell you how to do that inside RapidMiner. So the next step is to set the roles first. To set the roles, you can select set role. Just type set role here, and you can see this operator. You can just drag and drop on this line and it would automatically insert, because now once you have clicked on this, this would automatically take care of the splines. So this is going to be a long process, so I'm going to modify these a little bit. I'm just going to move them around so that everything is clear. So the first step was the input, and then the select attribute, and then the set role. So on the set role thing, you can select the attributes. The target role is going to be a label, because that label is for the target variable, and the attribute is going to be price. Okay, so this is done. The next thing is to define the categorical variable into dummy coding variable. So for that, you can select the operator as nominal to numerical. So you see here, you can just drag and drop this, and this would bring you these parameters. So for the attribute, which was neighborhood, which would be our only attribute, so we are going to select 1 here, and the attribute, so it automatically has guessed that neighborhood is going to be your categorical variable, which you are going to do the dummy coding. And if you scroll down here, if I would run this, I can show you the demonstration. You see here, the output data set has neighborhood segregated into 3 different columns. But if you see the name of the column, you will have east, north, and west with an equal to sign. So to change this, because normally when we define such kind of categorical variables or we pass these variables, we use an underscore sign. So you can check on this, and then you can execute again, and you will see that these names have changed with an underscore sign. So that's the usage, and that's the power of RapidMiner. You can do everything just by putting on all these parameters. Now the next task is split the data into test data and training data. To do that, you have an operator which is known as a split data. So once you have a split data, you can drag and drop it right in here, and this would be. So if you look here, the number of partitions can be edited by clicking on this, and this is going to be by default a ratio based. You can click on add entry, and you can save in as a training data with the 70% 70% data, and a test data with 30% data. So you can give here 0.7 and 0.3. To be note, this ratio is actually in between 0 and 1, so you have to define it with the point thing, 0.7 and 0.3. Click OK, and your data is going to be sampled, and the sampling type can also be defined, like you have a linear sampling where the top 70% rows would be considered as training and 30% remaining 30% would be considered for test. But you can have a shuffled one where random selected 70% rows would be considered for the training set and 30% would be considered for your test set. So this is how you can split the data. So if you want to cross check, just give a breakpoint here, and you can see that the data earlier was having 128 examples. That means 128 instances were present in our data set. But after the split, you can go back here, you can remove this, and you can execute again. After the split, it only had 90 examples. That means 30% was sent into the test set. So that's how you can verify that your data set has been split. Go back to your design perspective, and then you can have your next step, which is going to be your linear regression model. For that, you can go to Operators tab, give linear regression. You can select, drag and drop this here. Now this takes in input as training data set, which is first part of this operator output. So this is like 89 examples. You can just hover over the mouse and you can see the details according to. And then this is going to be your input for the linear regression. And the next tab is going to be your application of this model. So you will say apply model, and that's going to be your next. So this one we can drag down here, and here the output of this linear regression model which you see here, this one should not be presented directly into the result, but it should be going into the apply model thing, because we have to use the model which was created using this operator into your apply model thing, and we have to test the remaining 30% of the test data set into the unlabeled data. So this is actually a mandatory input, and this is the unlabeled data set. Now we have one more operator, and then we are good to go with the final result set. The remaining operator is to check for the performance of our model, which you can select here. So once you type performance, you can see here there are different modes of performance testing. So we are going to take regression because our model is regression. Now the output of this performance would be our final result set, and this would be connected with this lab here. Now we would also like to see the model which was created, so we can just connect these two and get the result of the apply model operator, see the result. And we would also want to see the predicted values in the output data set along with the original values. So for that you can connect this example also into your result set. So now we are all set, but one thing I would like to elaborate here, that performance operator is to check the quality of the model that is built. For that you have various options here. One is your root mean square error, which is the most important characteristic to check the quality of the model, and the other one is your R square, which is also known as squared correlation. So you can just check this and you can see the R square value also in the output. So we are all set here. I'm going to execute this and we'll see the output. So we have three different output set. So you can see the final data set which was created has price as a predicted variable. Alongside it has prediction values as well. So these look like pretty close and pretty good model. To check the quality of the model, you can go to linear regression tab and you can see various attributes and their coefficient and a standard error and p-value and t-statistics value. So if you see here, the neighborhood which was west is important prediction, Square feet is also an important predictor. Bathrooms are also important predictors, and offers are also important predictors. So based on the p-value, where the value is less than 0.05, we basically predict that as a good predictor. To check the actual result from the model itself, you can go to your performance vector tab, and there you can see the root mean squared value was this much, and the squared relation, which was r squared, is pretty close to 80%. So our model is pretty good. So that's how you can check for your values. You can do your linear regression, and that's how you can use RapidMiner. I hope you have learned from this tutorial. Thank you.